Lesson 102, Graphing Absolute Values on Inequality Symbols. So up until now, we have not used the absolute value when graphing inequalities. And that's because it's a little bit tricky. You have to think of the value of the absolute value of the number before you can graph it. You have to do a little bit more work to get there. So we understand that, let me drop in a number line here. We understand that a absolute value, let's say -3, for instance. The absolute value of -3 is 3, because if you look on your number line, the distance that -3 is from 0 is 3. So it doesn't matter. Let me do that again. It doesn't matter. I held it too long. It doesn't matter whether it's positive or whether it's negative, it's still 3 spaces from 0. 3 units, 3 spaces, whether you go to the left or whether you go to the right. It's all just 3 units. And that's what absolute value is. It is the distance from 0, the length. And a length is never negative. It is always positive. Absolutely. Even if you dig a hole, the hole still has an actual depth. It has a value of how far it is from the 0 or from the horizon, the space on the earth that is sea level. So the absolute value in an inequality is going to be a little bit more difficult to calculate because we have to think of it in terms not of positive and negative, but as a positive versus a negative. I don't know if that makes any sense. Let me show you instead. You'll get a much clearer picture if I show you rather than tell you. So in 102.1, we are asked to graph the absolute value of x is greater than 2. Okay? And if you hear racket in the background, that is my dog. He is taking a nap and eating a bone and doing all kinds of, yes, I'm talking about you, loud things at my feet. All right, so x is greater than 2. The absolute value of x is greater than 2. So we have to think about making this a true statement. We have to sub in values for x that when calculated from the absolute value would make this true. So what values of x when calculated as an absolute value make this a true statement are greater than 2? So 2.1, 2.5, yes. And because it's greater than 2, it's not including 2, is it? No. So it's not including 2. So if we were to put a circle around 2, that would be correct. Right? So anything greater than 2 on the positive side, we know for sure that is correct. Right? Now, if it were just x is greater than 2, this would be where we would stop. But it's the absolute value of x is greater than 2. So what about negative 2.5 or negative 2.1? We can't include negative 2 because if we put negative 2 in here, then 2 would not be greater than 2. It would be equal to. So we can't include 2. But we'd include 2.1, 2.5, 2.9, negative 3, negative 4, negative 5. Any of these negatives that we put in, the absolute value of them would be greater than 2. So we don't include the 2 because it's not got the equal sign under here, but we include any number that the absolute value of it would be greater than 2. And that is how we would graph this. And this is 101.1, sorry. So that's what that looks like. You have to take into account the absolute value. So let's do 102.2, see if we can get any more clarification on how this looks. Sorry, so now we're asked to graph the absolute value of x that is less than or equal to 3. Okay? So first of all, let's see the absolute values that are equal to 3 are 3 and negative 3, right? So now the absolute values that are less than 3, well, we know 2 is less than 3, 1 is less than 3, 0 is less than 3. Negative 1, the absolute value of negative 1 would be 1, so it's less than 3. The absolute value of negative 2 would be less than 3. And the absolute value of like negative 2.5, 2.6, all of those. So we can draw a line between the two of these. The absolute value of any of these numbers from 3 to negative 3 would be less than 3. Okay? Or equal to. We have that equal sign. So we include the 3. We fill in the circle because of the equal to symbol here. All right? So do we see how it works that way? So we've been given a greater symbol, which means we have to go on the outside. And we've been given a less than or equal to symbol, which means we have to go on the inside. And we have to include because of the equal. Let's try one that is a little bit different. 101 or 102.3. We are asked to graph the absolute value of x where it is less than a negative 4. So, knowing what we know about the absolute value of a number, is the absolute value of a number ever negative? No. It's always positive. Is there any positive number that is going to be less than a negative number? No. So there are absolutely no numbers that we can sub in for x that will give us an absolute value that is less than negative 4. They're all going to be greater than 4. So in order to make this a true statement, we cannot graph any numbers on this number line. This is the answer. So whenever you see the absolute value of x less than any negative number, you do not graph anything. And that is the correct answer. Okay? You have to use a little bit of logic whenever you are doing these inequality statements using absolute value. You have to think about what the problem or what the statement is saying. And let's move on to 102.4, and you can get a little bit more distinction in that. So we are graphing the absolute value of x is greater than a negative 4. Okay? All right? This one is also tricky. The absolute value of every number is 0 or a number greater than 0, right? Is 0 greater than negative 4? Yes. Is the absolute value of negative 1 greater than 4? Yes, because the absolute value of negative 1 is 1, so 1 is greater than 4. So in this instance, we graph every number on the number line because the absolute value of every number on the number line is going to be greater than any negative that you could put in here. If this is a negative, it doesn't matter. X is everything because X could be anything because the absolute value of everything is positive. So if the absolute value of everything is positive, then it's always, any number is always going to be greater than a negative number, right? So think about what is being asked and think about the symbol. Think about the symbol. Say it out loud to yourself. That's a technique that you can use to help you make sense of it. Sometimes just looking at the symbol isn't enough. We need to say it out loud so we can actually hear it and evaluate it. The absolute value, which is the positive value of any number, is greater than a negative 4. And it is. Okay, moving on to 102.5. And we are asked to graph the negative absolute value of x that is greater than or equal to a negative 3. Okay, so first things first, we do not like negatives on our variables, do we? No, we don't. And so when they are standing by themselves, we want to get rid of that negative. And we also know that the only way to get rid of a negative is to multiply or divide by a negative 1. And we know when dealing with inequalities, if we multiply or divide by a negative 1, that we have to flip our symbol because that changes the value of everything in our statement. So we will rewrite this as the absolute value of x is less than or equal to positive 3. Actually, I'm going to rewrite that over here so that it's bigger so we can see what we're doing. So we'd rewrite that as the absolute value of x is less than or equal to positive 3. We flip the symbol. Don't forget to flip the symbol when you multiply or divide by a negative number when you're dealing with inequalities. It makes a difference. It changes the value. So you have to flip the symbol. Okay? But now our statement says the absolute value of x is less than or equal to 3. So, in order for it to be equal to 3, it has to be a 3, and we're going to include that, or a negative 3, right? Wait a minute, isn't this the same as this right here? 102.5 is the same as 102.2. Isn't that the same statement? Yes. So we know, we've already worked it out. We know that it's going to be less than numbers that are smaller than 3 and numbers that are greater than negative 3. So because the absolute value of negative 2 is a positive 2. A positive 2 is less than 3. So we can just fill in that line in between the 2 points. All right. Let's do one final one, 102.6. And it asks us to graph the negative absolute value of x minus 2 that is greater than negative 5. All right, this is going to require us to do just a little bit of math. So first of all, let's add 2 to both sides. Okay. So that gives us a negative absolute value of x is less than a negative 3. You see that? Now we're going to multiply by a negative 1 to give us, I'm going to move this down to give us more room. There we go. That gives us more room just a little bit. All right, now we're going to multiply by a negative 1 so that we can get rid of the negative on our absolute value. We don't like that. So when we multiply or divide by negative 1, we flip the inequality. So we end up with the absolute value of x is less than 3. And we could take this and we can graph that by circling the 3, right? And we're going to circle this negative 3 because the absolute value of negative 3 is going to be 3. So we don't include the 3. We're going to get less than the 3. We know that if we put in negative 2.5, that would still be less than 3 because that's the absolute value would be 2.5. And we can include everything in here. It's basically the same as this right here without the equal sign underneath. Okay, we're just not filling in the circle. All right. So when you see these, the first thing you need to do is just get down to x. Solve just for the x. Then whenever you have to multiply or divide by a negative to get rid of the negative on the absolute value, that's just so you don't have to flip it in your head and make it an opposite, a negative later, right? We're simplifying it. Flip the sign. When you do that, flip the sign, take your statement, and then evaluate it. Once you get it down as simplified as possible, then graph it. Evaluate it out loud, say it so you can hear it, and then graph it on your line. That's all you have to do. If you have trouble with these, please message me, let me know. And that's all I have for lesson 102. So take the time to really listen and pay attention to what your inequalities are saying. Make them make sense. Okay? They should make sense. You should be able to understand what they're saying. And if you're having a struggle with that, then let me know and we'll dig into it and work on it together. That's all I have for lesson 102. I will see you in lesson 103.